Hi, my name is Esraa Ali. I'm a PhD student at ADAPT Research Center, Trinity College, Dublin. Today I'm going to present our paper with title A Probabilistic Approach to Personalized Type-Based Facet Ranking for POI suggestion. This work was done under the supervision of Annalina Captou, Lawless, and Owen Conlan. Facet search systems offer users meaningful facets to refine their search queries and narrow down search results quickly. We focus on the type-based facets. We call them T-Facets, T-Facets, and they represent the categories of the resources being searched. They are usually organized in large multi-level taxonomies. Of course, as the magnitude of the data increases, so does uh, the number of the facets, and it becomes really hard to display them all at once. So ranking is needed to select the appropriate subtree of the T-facets to present to the user. Our work aims at answering the following research question: does personalizing the T-facet ranking using probabilistic scoring models minimize user efforts to fulfill their search needs or not? This is an example from Amazon that we use every day. And we can see T-facets organized in a small tree in the corner of the page, and the user can use them to filter the products by their type first before using the other types of facets. The usual search scenario starts by the user entering a search query, Star Wars in this case, and then the search engine ranks the resources, then groups and selects the relevant subtree of the type-based facets to display to the user. Existing research focused on the problem of facet ranking in general and how this can be personalized. They make use of individual user models, collaborative filtering models, or a mixture between two approaches in order to rank the facets to the user. But the case of the type-based facets remain not handled or not addressed by the earlier research. Methods don't provide means to order the hierarchy of the T-facets, the whole tree. They don't. Our approach exploits user past preferences to build a topic-based user profile, and we use this profile to rank the new T facets. It mainly consists of two main steps. The first step is a T-facet scoring steps. At this step, we assign a score to each leaf node in the T-facet tree. In this example, like the aquarium, the laser tag, or the Christmas market or conference. And after assigning this score, it should reflect the relevance of this T-facet to both the user and the current query. In the second step, we use the aggregated score for the leaf node T-facets in order to rank their ancestors in the tree. In this example, like the events and arts and entertainment. For the first step, we use probabilistic models in order to generate the score for each leaf node T-facet. So the score of the current T-facet Fi is the probability that this facet matches one of the facets existing in user profiles. By this, we mean a facet that was rated previously by the user. multiplied by the probability that this user T-facet is relevant to the query and is favored by the user. Well, the exact details about this equation and other models exist in the paper, but the main idea is that the relevance probability determined by this blue equation is basically the probability that this T-facet is rated positively by the user multiplied by the probability that this facet is relevant to the query. This probability that this facet is relevant to the query or not is estimated is estimated from the document level search engine, as it arranges the relevant resources to the user first. The second part of the equation is the probability that this T-facet matches one of the T-facets previously rated by the user. We experimented with two different methods to estimate this value. The first one only considers T-facet, which exactly matches one of the user T-facets. In this case, if a new T-facet added in the system, the approach will assign 0 as score to it. So it only handles the T-facets that was seen before by the user. The second method is more flexible in handling new T-facets, as it considers the nearest user T-facet in its meaning. We use for this the cosine similarity between the BERT vectors of the T-facets. So if two facets are similar in meaning, then we adopt their probabilities in the model. For the second step in the T-facet tree building, we experimented also with two simple methods, straightforward methods. They use a predefined fixed number of T-facets to be displayed at each level. So in this example, we see the system is configured to display only two levels. In the first level, 3 parent level 1 T-facets are displayed, and each has 3 children, and higher categories are sorted by the average score of their top children. The implemented approach was evaluated using a trick contextual suggestion dataset. It's a personalized point of interest recommendation task. We solved the POI suggestion by ranking the types of the venues as T-facets. The POIs are linked to their Foursquare profiles. The T-facets are derived from Foursquare categories taxonomy. It's a very large, high 5-level taxonomy with more than 700 T-facets in it, so it was rich enough for this task. We report the results for our different models proposed in the paper, and our evaluation, we measure the extent to which this ranked T-facet tree minimize the user effort to reach first relevant POI using two metrics. The first metric is F-scan, and it calculates how many facets and documents the user had to scan to reach the first relevant result, where the second metric is the number of actions, and it represents how many clicks the user had to make in order to reach the first relevant result. These two metrics were suggested by NX fastest search task, and it was adopted in our evaluation. We can see that the model one, it's the probabilistic no background model with cosine similarity outperformed other probabilistic models. Here we compare our results against other personalized fast scoring baselines using files in TrexCS only contain 30 or 60 POIs in their user profiles, so the user profile was very limited. This problem affected the categorical distribution of the T-Facets. At the end, this gave advantage for the collaborative models over the individual user personalization models. Still, the probabilistic model, the personalized one, achieved comparable results to existing baselines. So in this presentation, I try to give a very quick brief overview about our approach to personalized type-based fast ranking. Our two-step approach considers the hierarchical nature of the T-facets as well as user individual preferences. The probabilistic models have shown promising results given the limited user profiles in the TrexCS dataset. After submitting the paper, we developed another personalized T-facet scoring method using vector space models, and it achieved very good results. We also customized and experimented with a large scale dataset, larger dataset. It's a Yelp Open dataset, and we wanted to compare how the approach performance in TrexCS and in Yelp Open dataset. Well, that's it for me.